Okay, question 1. This is 4.3 CPO, course practice. The input voltage is 12 volts in a transformer, and it's ideal. And the number of turns is 100. The secondary is 650. What's the output? I'm gonna go fast through this section because it's very, very easy. Okay, this is the formula. Okay, we're gonna continue. V out is how much? Number of V out, we're trying to find it. Okay, over V in is 12 equals NS, and the secondary is 650 over NP, which is 100. Okay, V out, so you're gonna get 650 times 12 divided by 100. Okay, you're gonna get 78. Very easy. Based on the number of turns in transformer, the transformer is what? Step up or step down? Akid step up, right? Mish step down. Why, man? Look at the turns. It's higher than the secondary turns is higher than the first one. Okay. Question 2. A transformer has 300 turns in the primary and 50 in the secondary. The current in the primary is 5 and the secondary is 27. The efficiency of the transformer is what? Let me see. Okay, to find efficiency, although they don't really have much given here, you need to figure out. You need to kind of figure out what's going on. Okay, when you have currents, when you're working with currents, by the way, the only time currents will apply, you guys know there's a formula for currents, right? The same way we have V out over V in equals NS over NP. You have I in over I out is NS over NP. For current, it's the opposite. Instead of I out over I in, it's I in over I out. Okay. So this is the formula for currents. This works if it was ideal only. Okay, so the only thing you can do here, they gave you the currents for this transformer, and they're saying to calculate the efficiency. How do you do this? If you're ever faced with a problem like this, you need to calculate the current that it should give, and then compare it with the current that it actually gave as the output, and check the efficiency. Okay, so let's apply this formula. I in is 5. Okay, we don't know I out. Suppose you don't know I out. We're trying to see how much theoretically it would give me as an I out. Okay, equals NS over NP. Secondary coil 50 over 300. Okay, you're gonna get 5 times 300 divided by 50. You're gonna get 30. Okay, so I out should be 30, but how much did it give me? 27. Okay, so how do you calculate it? You just do how much it gave you over how much it's supposed to give you, and you get 0.9, which is 90%. Right? Very easy. Based on the number of turns, it is obviously step down because it has less turns in the secondary coil. I'm not gonna spend too much time on that. Okay, a step up, it increases. Ideal transformer, what does it do to power? It doesn't change it. Okay, a real transformer decreases. Real transformers are not ideal. Okay, they have their efficiency is not 100%. Every real transformer on Earth, none of them has 100% efficiency. So it decreases the output power, since it's not 100% efficient. If a transformer increases the output voltage, it decreases the output current. Since you have P is equal to IV, if you increase this, then this should decrease. Okay, because the power is staying the same almost. Okay, question 4 is considered below a setup of a transformer connected to a bulb. Let's label it. Okay, so the outside is the laminated core. Here's the primary coil. This is the secondary coil. Very simple. The process by which a changing current in the primary coil causes a changing current in the secondary coil is called electromagnetic induction, right? Just memorize it. You should know it. Okay, electromagnetic induction. Because it goes from primary coil to the secondary coil, so that's why it's called induced. Okay, and it's electromagnetic because you're working with both electricity, the EMF, plus the magnetic field. So that's why it's called electromagnetic. Okay, what is the frequency in the light bulb? It's going to stay 60 hertz. Frequency, we said it doesn't change. 5. This is what's happening here. What is the device? Of course, it's a transformer. Assuming no power losses, so 100% efficiency. Okay. The potential difference across bulb 2 is how much? Let's do it. V out over V in. I'm telling you, my open board is lagging. This program آخر مدة والله مش عاجبني. Okay, V out over V in is equal to NS over NP. طيب يلا V out قد ايه؟ V out we don't know, we're trying to figure it out. Over V in 120 is equal to NS secondary 50 over primary 800. طيب 120 ضرب 50 divided by 800. Okay, you get 7.5. Okay, at 60 volt DC supply is used instead of the 120 volt AC. What's gonna happen? They said DC. Okay, pay attention to this. It doesn't mean it's gonna decrease brightness. No, please pay attention. DC شو معناتها? Can a transformer work on DC? No, so it's gonna go off. Okay, question 6. Okay, name the parts of the transformer. What induces the EMF? Okay, it's the secondary coil. Which one gives the EMF off? Okay, it's the secondary coil. What links it? Obviously the soft iron core. And what generates the alternating magnetic field? The primary coil. Let's draw it as Saria. You have this over here. Okay, and you have this. Hey. Okay, this generates a magnetic field. The core links it here, and the secondary coil gives it off. Okay, and induces it. Like, question 7. A transformer has 760 in the primary and 100 in the secondary. So what is this? Akid, since the secondary NS is less than NP, it's a step-down transformer. Question 8. A transformer has 60 in the primary and N in the secondary. The peak EMF in the primary and secondary are 48 and 240. What is the number of turns in the secondary? Same formula we use all the time. V out or VNI. 1 second. V out over Vn is equal to NS over NP. V out is 240. Vn is 48, and primary is 60, and sorry, ns over np. For ns, we don't know how much it is, and primary, it's 60, it's given. Yeah, let's do it. 240 times 60 divided by 48, 300. The current in the primary coil is 4 amperes, and the current in the secondary coil is 0.72 amperes. What's the input power of the transformer? Okay, how do you find power? Power is equal to IV. طيب الفولتج is 60 so the voltage is not 60. The voltage is 48, and the current is 4. If I do 48 times 4, it should be 192. Yeah. What's the output power of the transformer? Okay, 0.72 times 240. You get 172.8, so approximately 173. How do you find efficiency? Output divided by input times 100. You're going to get 173 divided by 192, and you get 90%. Yeah, that's pretty much it. Question 9. Primary is this, secondary is this. What's the efficiency? Okay, you find the power here, and then you find the power here. How do you find the power here? I times V. So 2.2 times 9. Let's see, 2.2 times 9. 19.8. فهون عندك 19.8 watts. هون ادي عندك 0.162 times 110. Why 0.162? Because it's given in milli, huh? It's not given in amperes directly, it's given in milliamperes. Type, how do you do this? You divide the output by the input, and you get 0.9. So in percentage, that's 90%. Thank you so much for watching 4.3, and good luck in your exam. Oh, wait, I'm gonna wait 20 more seconds because I need to be above 8 minutes. Let me up for 15 seconds. Okay, I actually don't know what to talk about. Hold up. Yeah, I'm just gonna keep on saying random things for 4 more seconds, 3 more seconds, 2 more seconds, 1 more second, and that is above 8 minutes. Thank you so much for watching, and good luck in your exam.